Thank you for the introduction, Nari. Hi, everyone. My name is Nikhil Srihari, and I'm a technical marketing engineer for deep learning here at NVIDIA. I'm here to talk about building a custom voice-based virtual assistant using NVIDIA's conversational AI framework and Rasa. With me, I have Shashank Verma, who is also a technical marketing engineer for deep learning at NVIDIA, and Arun Venkatesan, who is the product manager for Jarvis at NVIDIA. Okay, so here is the agenda for this talk, right? We start off by defining our use case, and then we introduce NVIDIA's Jarvis. Next, we take you through building a virtual assistant with Jarvis and Rasa, followed by a discussion on using NVIDIA Transfer Learning Toolkit, or TLT for short, to fine-tune our models. And then we add voice support to this Jarvis and Rasa virtual assistant. This is finally followed by conclusion and Q&A. Let us start with a demo video to understand what exactly we'll be building here.
How is the weather?
For which location?
In London?
It is clear in London at the moment. The temperature is 16 degrees, the humidity is 77%, and the wind speed is 7 miles per hour.
Is it raining in Los Angeles?
It is sunny in Los Angeles at the moment. The temperature is 22 degrees, the humidity is 66%, and the wind speed is 0 miles per hour.
Is it hot in Austin?
It is clear in Austin at the moment. The temperature is 26 degrees, the humidity is 74%, and the wind speed is 0 miles per hour.
How is the weather?
For which location?
In London?
So this is what we'll be building here today. We're going to build a weather chatbot as a web application. To build this chatbot, we'll be using NVIDIA's Jarvis and Transfer Learning Toolkit, TLT for short, along with Rasa. We'll be using NVIDIA Jarvis for ASR, TTS, and NLP, and Rasa for dialogue management. With NVIDIA's Transfer Learning Toolkit, we'll train the Jarvis NLP models. Before we dive into building a virtual assistant, let us first understand what Jarvis is and why we need it. Conversational AI is being used across a rapidly growing number of fields. For AI researchers, interest in improving the state of the art for conversational AI is at an all-time high, with breakthrough advancements leveraging deep learning for speech recognition, synthesis, and natural language understanding all occurring within the past few years. When BERT was published by Google only 2 years ago, it set a new state-of-the-art score for benchmark tasks in natural language understanding and renewed interest in the field. At the time of publication, BERT models were considered quite large, with between 110 million and 350 million parameters in the model. Since then, we have seen the parameter counts for language models grow into billions and trillions of parameters. To understand the value of Jarvis, we need to understand the challenges in building a conversational AI application. Bleeding-edge conversational AI is quite complicated. The algorithms can be challenging to implement based on research papers. They can be hard to train to convergence and reach acceptable accuracy. It is difficult to make them efficient and cost-effective to deploy and to meet the latency constraints for practical problems. Take the example of a voice assistant, like the one we just saw in the demo. We would like the response from the voice assistant to be within a reasonable amount of time so as to maintain good user experience. You can't have the user waiting for more than a second to get a response. In addition to all this, many customers need models to be customized for their specific needs and also need the flexibility to deploy on their infrastructure of choice, be it cloud, on-premise, or on edge. Enter Jarvis. Jarvis is a fully accelerated framework for multimodal conversational AI services. Going from right to left in the diagram there, Jarvis has multiple AI services, including speech recognition, natural language understanding, speech synthesis, that are wrapped up in a container and are accessible via gRPC endpoints. As you can see, computer vision and dialogue manager will be available in future versions. To its right, you have the training toolkit. You have the training tools Nemo and TLT that can help you with training and customization of your models. On the far left, you have NGC, from where you can access all the software and models. Let me quickly go over how Jarvis helps address the key challenges facing conversational AI developers. Accuracy. Jarvis has SOTA models trained on several thousand hours of data, and NVIDIA Research is committed to continuously improving the models that are available so the customers can continue to keep up with the state of the art. Latency. The entire pipeline is optimized and can achieve less than 300 milliseconds for a task that can take up to 25 seconds on a CPU, enabling true real-time conversation. Multimodality. Jarvis supports multiple input modalities, including audio, vision, text, and fuse them together to create a more realistic conversational experience. Customization. With Nemo and TLT, we can use these tools to customize the models to a particular customer's industry and use case. Ease of deployment. Jarvis is packaged as Docker containers or Helm charts and can be deployed with one click on any infrastructure. Jarvis uses inference for efficient deployment of AI models at scale. It uses Triton Inference Server for efficient deployment of models at scale. The models are optimized with TensorRT to help achieve the best possible performance on NVIDIA GPUs. The speech recognition service, or ASR, can operate in both batch mode and streaming mode and can support a variety of sampling rates from 8 kHz to 48 kHz. The public release of ASR consists of CitrusNet, Jasper, and QuartzNet as the available acoustic models. Similarly, the speech synthesis service can also operate in batch mode as well as streaming mode and is end-to-end optimized. The text-to-speech models are based on Talkatron 2 and Waveglow architectures and have been trained on LG Speech dataset. In the near future, Jarvis will support models based on fast-pitch architecture developed by NVIDIA for MEL spectrum generation and Hi-Fi GAN for voice encoding. These models will offer significant improvement in quality and throughput, as well as features like control of pitch and duration. The NLP service consists of high-level as well as low-level APIs. The high-level APIs include entity recognition, intent slot identification, punctuation, and question answering. The low-level APIs provide generic NLP services for custom use cases. For example, the classified text function can be used for sentence classification, domain recognition, language identification, etc. Our NLP models are based on BERT and BERT large architectures and were trained on task-specific datasets. In the near future, Jarvis will also include neural machine translation capabilities to support multiple bidirectional language pairs. Now that we know what Jarvis is, we can start building our virtual assistant. Here are some details on what we are building. Please note that due to time constraints, we won't go into the details of Rasa itself, right? So we're using Jarvis for NLP and Rasa for dialogue management. Hence, we won't be using any Rasa NLP models, right? So we don't need to provide any NLP training data for Rasa, but we do need to provide stories for the Rasa dialogue manager. At this point, you might be asking why we need Jarvis NLP. As I already mentioned earlier, the most important advantages of Jarvis NLP are that Jarvis is highly scalable and it is optimized for very low latencies. The UI for our user interaction is going to be command line. Now that we know why we need Jarvis NLP here, let us take a look at the architecture of our solution during inference. The text input from the user is sent to Rasa, which in turn sends it to Jarvis NLP service to identify the intent entities. This is then sent back to the Rasa dialog manager, which is responsible for generating the final response. This response is then sent back to the user. Let us understand how exactly we integrate Jarvis NLP with Rasa. Rasa offers both NLU and dialog management capabilities. Rasa offers both NLU and dialog management capabilities. Rasa NLU is exposed as a pipeline made up of multiple components. A sample Rasa NLU pipeline can be seen here, right? Rasa allows defining and adding custom NLP components to the Rasa NLU pipeline. So here, we add a custom NLP component to the Rasa NLP pipeline, and this custom NLP component is the one that is going to be responsible for making gRPC calls to Jarvis speech server. So this is how we define our custom NLP component, Jarvis NLP component, and it extends the Rasa's component base class. And this is what our pipeline looks like. It consists of only the Jarvis NLP component and nothing else. So here is what our Jarvis NLP component looks like, right? So as you can see here, the key function here is the process function, which is responsible for inference. And this just calls the Jarvis NLP wrappers get intent entities method. So let us look at the Jarvis NLP wrapper file in a little more detail. This file is the one that is responsible for actually making the gRPC calls to Jarvis NLP service. This is a simple 3-step process. We first import the Jarvis client libraries. Second, we create a gRPC channel to the Jarvis speech server. In the third step, we first create a request object with our input data and then perform the actual gRPC request. As you can see here, the whole process is pretty simple and just takes about 12 lines of code. So far, we have understood how our inference pipeline works to take the user input and generate a response and return it back to the user. We've also seen how to perform inference on Jarvis NLP and its integration with Rasa for dialog management. Now let us understand how to train the Jarvis NLP model on our custom data. Over to Shashank more on this.
So hi everyone. So far my colleague Nikhil talked about using Jarvis for Jarvis along with Rasa. So I'm Shashank and I'm talking about training models using NVIDIA Transfer Learning Toolkit, or TLT for short, and then deploying those models in NVIDIA Jarvis for inference. So Jarvis speech recognition and NLP models can be trained or fine-tuned using NVIDIA Transfer Learning Toolkit, or TLT for short. TLT is a simplified AI training toolkit that eliminates the need of time. It eliminates the time-consuming process of training these really large NLP models from scratch. It reduces the engineering efforts significantly by rapidly training with NVIDIA purpose-built models to achieve high throughput and accuracy in a very short duration of time, right? And we'll see soon how we can do this, right? What makes TLT stand out as a training tool? Well, first, it enables developers with limited AI expertise to create highly accurate AI models for production-level deployments. Next, it follows the zero coding paradigm. That means you don't need to write much code at all, actually any code at all. You just need to issue a few commands from the TLT command line interface to actually get started. Right? All the complexity is abstracted away in the form of specification or configuration files, right? Which you can use just the default ones to get started, or you can write from scratch. So most of the complexity is hidden away. All you need is the clean and easy to use TLT command line interface. And then TLT uses tensor cores out of the box to give you the highest training performance possible, right? And best of all, it is integrated with NVIDIA Jarvis. Right, so you can build beautiful virtual assistants like the one that we saw. Right, so setting up TLT is quite straightforward as well. You just need to do these 3 steps. Right, you need to log into the NVIDIA GPU Cloud Docker registry, because TLT pulls some Docker containers in the background, and it runs all its processes with that. Right, so you simply need to log into the NGC Docker registry, and if you don't already have an NGC account, go ahead and sign right up. It takes like 5 minutes to do that, right? The next, you need to create a virtual environment to isolate your dependencies. This is just in general good practice. And then you can install TLT using pip. So now TLT can be used to do transfer learning for both ASR and NLP models. But in this case, we'll be focusing on the intent and slot model, slot classification task. And just to highlight some of the salient bits, you can do everything in TLT from getting default configurations, data preprocessing, training, or fine-tuning your models, even exporting it to other formats, right? Especially like the Onyx format or the eJarvis format, which can be used for deployment in Jarvis. Right, in TLT, you can train or fine-tune a model with a BERT-based encoder, which is pre-trained on some generic NLP tasks already, right? And you can see this in the diagram over here. So decoder layers are added on top of that, and then you can train this resultant model using TLT, and this will give you a .tlt file. You can use this file to generate evaluation metrics to see how well your training did, right? You can fine-tune your model further or export it to other formats. And here, for instance, the diagram here shows the in general end-to-end workflow with the most important subtasks in green and the resultant assets in white. Right, so here you can see the whole pipeline. You can download the specs, process the data for a format suitable for training in TLT. You can train the model, you can export the model, and everything, right? The whole good deal, right? But then I told you earlier that there is minimal effort required to use TLT. All the complexity of all the parameters are hidden away in specification files. Like I mentioned earlier, you can choose to use the default spec file that comes out of the box, or you can write one from scratch if you want to. So there's definitely high level of configurability still in your hands. Everything is still in your control here, right? If you want to. So I'll give you an example. For instance, here on your screen is the example to convert your data in a format that can be used for TLT training. You need to provide the path to the spec file, the source data directory, and the target data directory. And then you're all good to go, right? And then moving forward, here's another one. This is one for training. You can pass your spec file again, and then which has all the configurations, like you can see on the right. And then you can provide the number of GPUs you want to use for training, the encryption key. And on top of that, you can also override some of the configurations in your spec file just to make it even more easier for you. Next, now that we have an eJarvis file, so I think one thing I forgot to mention is that there's a TLT export command which can export your model to the eJarvis format. And this is the format that we'll use for deployment in Jarvis. And then next that you have your eJarvis file now. So what do you do next to deploy it? Well, you use something called as a Jarvis Service Maker utility, right? Which is a utility to combine all the necessary assets required for deployment, like the model weights, the vocabulary files, the graphs and such, right? And then it optimizes it for deployment on the target environment, right? And this is done in 2 steps, Jarvis build and Jarvis deploy, which are like 1 command each. So they're all simple to use as well. And after this, you can simply go ahead, once you have the model repository ready, the optimized model repository, you can go ahead and start your Jarvis server. And again, we have quick start scripts to help you do all of this. And you can find this resource on the NGC catalog page, like is shown here. And after your server is set up, you can send inference queries through gRPC or the Jarvis Python API. And this here is an example of the Jarvis Python API. So we're just creating a channel here. We're creating the server object. We're sending the request, and that's pretty much it. It's doing inferences as easy as that. One thing I want to mention is that there's extensive documentation available online for doing all of this. There are demos, there are examples, there are tutorials and everything available. So you can just get started with all of that very quickly. So far we have talked about using Jarvis, NLP, and Rasa dialog management, right? And we also saw how you can use TLT to build your custom intent and slot model with your own data, right? Next you can let's see about how you can add voice support to your assistant, that is speech recognition and speech synthesis capabilities as well. So here's the architecture diagram for the Jarvis Rasa virtual assistant, right? That demonstrates the integration of Rasa and Jarvis speech services, right? As the user talks on the left, there is a voice input into the client application, which makes a gRPC service call to the Jarvis server, which is hosting the speech recognition service, right? It returns the transcript back. To the client application, which then forwarded to the Rasa server this time, which is running a Jarvis NLP component as a custom NLP component, right? Which forwards the request to the Jarvis server to return back the intents and slots that it detects. Based on that, a dialog management decision is made from using Rasa Dialog Manager, and then it returns this response back for speech synthesis call to Jarvis AI services again, right? And this voice output is returned back to the user. So like this, you have an end-to-end pipeline where you can talk to the assistant and it can talk back to you, right? So the full source code and the steps to actually try this out is available on NGC. So you can see exactly how the whole process works. So please go ahead and try that out if you want to. So now to wrap up this session, I'll share a few resources to help you get started with Jarvis and TLT. We have many demos all over the place that show virtual assistants, call center applications. For instance, the one that you saw, the one that Nikhil showed earlier is also there, the virtual assistant, and you can go check out the source code, how exactly it works and everything. My favorite one is Misty. The second one from the start, it's a virtual assistant which was featured in the NVIDIA keynote. So go check out the demo. Apart from the demos, we have various sample applications, tutorials, notebooks, and developer blogs to help you get started, get creative, and build your own applications if you want to. So that's it, I think. Please go ahead and try Jarvis Open Beta. Thank you.